Okay, so we're all in the middle of this huge energy transition, right? Electric cars are becoming the norm, heat pumps are replacing old furnaces. But what if all these new gadgets could do something more than just their main job? What if they're holding a secret that could completely transform our energy grid? So, this explainer is based on a really fascinating report from the Austrian Institute of Technology. And we're going to dive into this idea of a hidden power source, one that's, believe it or not, sitting right there in your home and could be the key to preventing blackouts and securing a green energy future. Yeah, this is about way more than just cleaner air. The move to electrify basically everything, our cars, our heating, is creating this massive, totally untapped resource. You can think of it like a giant virtual battery, spread out in little pieces across millions and millions of homes. And I mean, just look at the scale of this. The International Energy Agency is projecting that by 2030, we're going to have something like 600 million heat pumps around the world. And that's not even counting the explosion in electric vehicles. That is a staggering amount of potential energy just waiting to be coordinated. The thing is, these devices don't just have to sit there and suck up power. They can be smart, they can be flexible, they can act like shock absorbers for the entire grid, intelligently adjusting when they draw electricity. And that's absolutely crucial as we add more renewables like wind and solar that, aren't always on. But what does that actually mean, this flexibility? All right, so that brings us to the core idea here, grid flexibility. At its heart, it's really simple. It's just the ability of a device to change its normal routine without messing up its main job. Basically, it's all about shifting when you use energy. You can either power down a bit when the grid is totally stressed out, that's what they call positive flexibility, or you can power up when there's tons of clean energy available, like on a super windy day, that's negative flexibility. Here's a perfect example to make this super clear. Imagine your smart heat pump gets a signal that power is cheap and plentiful, so it quietly preheats your home just a tiny bit. Later, when everyone gets home from work and turns everything on, the grid gets strained. Your heat pump can just turn off for a little while. The best part? You'd never even notice. You stay perfectly comfortable, but you just helped keep the grid stable. So you hear all that and you think, wow, the potential here is massive, right? Millions of devices all ready to help. But, and this is a big but, when you start applying some real-world constraints, that potential starts to shrink. A lot. It's like a funnel. Let's use this case study from Austria to see exactly how it works. Okay, so let's start at the top of the funnel, the absolute maximum. In Austria, under a pretty conservative estimate, they're looking at nearly 850,000 heat pumps installed by 2030. That's our theoretical starting point. So the first question is, how many of these can actually do this? Are they smart enough? And the answer is pretty surprising. Almost all of them. Since 2015, most new heat pumps come with the right interfaces built in. So get this, the technology is not the problem here. The hardware is ready. And boom, here's where we hit the first big wall. It's us, it's people. When they surveyed folks in Austria, only about 30% said they were definitely willing to let their device participate in one of these programs. That's a huge drop-off right at the start. So when you take that 30%, just the people who are a definite yes, and apply it to all those technically ready heat pumps, well, the number just tanks. We go from almost 800,000 down to under 240,000. We've lost over 70% of our potential in a single step. And it doesn't even stop there, because even for the people who do sign up, you have to look at what happens next, in their day-to-day lives. Sure, things like a really cold day can limit what a heat pump can do, but the biggest hit, by far, comes from human behavior. Studies show that people manually override the smart system up to 35% of the time, so that shrinks our available resource even more. And that really gets to the absolute core of this whole thing. The single biggest roadblock to unlocking this incredible resource isn't a technical one. It's a societal one. It's not about the hardware. The real challenge is people. It's a human problem of trust, convenience, and communication. Okay, so after running through that entire funnel, after all those real-world deductions, what are we actually left with? How much power does this virtual battery really hold for a country like Austria? The final number they landed on is 135 megawatts of what's called positive flexibility. That's 135 megawatts of demand that can be turned off when the grid is screaming for help. Now, that sounds like a lot, right? But what does that mean in the real world?
Well, that 135 megawatts is actually more than 1% of Austria's entire peak electricity demand. Now, it's not a magic bullet that solves everything, but that is a serious resource. It's enough power to offset the demand of a small city, and it could be the difference maker that prevents building a whole new power plant.
So, if the problem is human, then the solutions have to be human-centric too, right? The report is pretty clear on how we can start to widen that funnel and get more of this hidden power online. It all comes down to closing that human gap. We're talking about making things simple, building trust, and making sure it's actually worth it for people. We need to train the installers, create certifications so people know what they're getting, and just make the whole process easy and rewarding. And look, getting this right isn't just a nice to have. It's absolutely fundamental if we want a stable, affordable, and green energy grid. So, at the end of the day, the tech is ready to go. It's here. It works. The real challenge, the real work, is figuring out how to get more people on board, to widen the neck of that funnel. The success of this whole energy transition might not depend on the next big engineering breakthrough, but on whether we can build the systems and the trust to unlock the power we already have. So, the technology is ready. The real question is, are we?